Then I would like to introduce Michael Medin, talking about NSClient. Yeah, thank you very much, and welcome.
Hello, my name is Michael Medin, and I'm going to talk a little bit about NSClient++ and sort of how to integrate it with the rest of the world. So essentially, this talk is going to be a lot similar to all the other talks this morning. So we're going to have graphite in there, we're going to have Grafana in there, and we're going to have elastic in there. So you're going to feel just at home. But the first question you're asking yourself is, why am I here? And that's something I've been asking myself a lot too. And the reason is actually this. You know, I got this Icinga t-shirt a couple of years back, and it's starting to look a bit worse for wear. And you know, holes in the and then you know, I keep telling my children that they can't have clothes with holes in them, and mine has like big holes under their arms and things like that. So I figured, you know, last year when they had Icinga Camp in Stockholm, you know, I'd go do a presentation, get a free t-shirt. There was no t-shirt. Yeah. So this year I thought, yeah, you know, in Germany there has to be a t-shirt. There is no t-shirt. So essentially that's it. Thank you. No, I might actually do some presentation bits after all. And as I said, my name is Michael, love to build things, blue plastic pieces, yellow plastic pieces, and other things like NSClient. Then I have two daughters, and if you look to the left on your, yeah, well, that way, you'll notice a striking similarity to me. Oh, sorry, yeah, there. Unfortunately, so she's probably not going to be too popular given that she has the grumpy face. But this is me skiing in Trysil, and I was, I don't know, yay high. And since then I've never skied in my entire life because, you know, snow is dangerous, and I cried a lot. And then last year we went skiing with work, and I figured I'll try it, and I loved it. So I went back to Trysil last week and skied again and had an awesome time. And the reason why I'm telling you this is not just stalling for time, because I don't actually have a presentation. It's also I have a bit of a cough, so you'll have to excuse me when I probably consume some water and cough into your ear or something. But that's not why we're here, right? Because we're going to talk about NSClient, or at least how to get Windows to play along. And NSClient is a general purpose agent. This means that it supports various protocols, supports various paradigms, supports checks, it supports scripts, and you know, the usual stuff, right? That you need to do your monitoring. It's modular by design, and this in essence means that it is highly complicated, is probably what you should say, right? Because extensible is a fancy word for complicated in reality. It's been around for quite some time, 2003, I think. First commit is 2005, but that was essentially the entire program. So presumably I wrote it before then. It's also open source, and not like a lot of other tools out there, open core. So essentially, no matter how much money you give to me, there will be no special version for you, unfortunately. And I talked to Brent about that. Apparently that's a problem, because people want to pay for the special version. So I probably need to solve that somehow. It runs on Linux. Not many people know this because it's generally thought as a Windows agent, but it runs just fine on Linux as well. And 0.5.2 is the stable version. Hopefully we will get 0.5.3 in April, or earlier if we're lucky. But we'll get into that a bit more. I've usually have this whole deck where, you know, I have the change log, change by change, and I've tried to compress it a bit for this presentation. So essentially we're going to do all the 0.4x versions in one slide. So we've got Linux support, modern Windows support, simplified monitoring, web UI, remote page, new installer. Right. Then we can move on to something slightly more interesting. That is the 0.5.0 version, where we got fancy new web UI. But we also got things like metrics, collect-D supports, and we fixed count. So if you're using an older version, don't use count because it doesn't work. Then we have 0.5.1, where we had a brand new event subsystem. We wrote some documentation and fixed the installer so it actually works, so you can customize it and things like that. And the latest version, which is out a couple of months now, we got a RESTful API, which means that you can actually talk to NSClient and do a lot of cool stuff with it. We also got some documentation, as always. We got something called zip modules, which I'll talk a bit about later. And we also got something I think is pretty cool, which is a native OP5 client, which means that if you're in Sweden and you're using the OP5 monitoring tool, then you can just use that. Otherwise, you'll have to, you know, do a lot of configuration and stuff like that. But this is something that I think is important, because the normal way where you do this is that you install NSClient on a lot of machines, and then you configure a lot of machines in your monitoring solution. What we've done here is sort of turn this around. So in essence, what you do is you install NSClient, and NSClient goes to your monitoring tools and says, hello, monitor me. And this makes managing it a lot easier, especially if you have some fancy scripts that can sort of tell what should be monitored and how it should be monitored, things like that. So then you can essentially get an effortless monitoring solution set up. So this brings us to the next version, where we will be getting an NSClient. That's what we're going to talk a bit at today. And an Icinga client, hopefully. We're going to get something called remote modules and more documentation. This is usually where I throw in my please don't be angry slide, and this is something I do in my spare time, generally. So sometimes I'm not doing this, which means that if you file a ticket and you're unlucky, I'm away skiing for a week and I won't look at it. That said, we do have sponsorings, donations, and support. So feel free to give me money anyway. You won't get anything for it, but money is always fun. Big thank you to my sponsors, OP5, Centurion, and West Phoenix. And with that, we're going to get to almost the actual presentation. I'm going to stall a bit more for time, but soon it's going to happen. There are some monitoring paradigms out there, especially if you're coming from the Nagios world, because they talk about things like active monitoring, where essentially your monitoring solution goes to your client and says, hi, are you doing fine? And it usually responds, yes. And it does this every 5 minutes. And I've always been a bit bothered by this paradigm, because it's a bit like if you're, out skiing and you happen to break your leg, you probably want your doctor to look at it, right? But it's not like you go to your doctor and tell him, call me every 5 minutes, ask me if I've broken my leg. It doesn't really make sense, right? Because it's much easier to call him when you've actually done it, because otherwise you'll spend a lot of time answering the phone, right? And some people say that the solution to this is what's called passive monitoring, which essentially means that you have a scheduler running on your monitored server and pushes the status every 5 minutes. So this would be you calling your doctor every 5 minutes saying, hey, I'm doing fine, you don't have to look at my leg. It's still a bit clunky, I think. Essentially, what we're talking about here is firewall paradigms, right? Do you want to open your connection this way or that way? I think we can do better than this. I think we can actually do monitoring that is smart, that is better, and does a lot of more interesting things than say, are you doing fine? Yes, every 5 minutes. So I have something in NSClient which I usually call real-time monitoring, but essentially it's some sort of smart check, A good example of this is a log file. If there's an error in the log file, we report it. If there is no error in the log file, we don't alert on it. So there's no need for anyone to sort of go every 5 minutes asking, is there anything new happening in your log? And the other upside of this is that instead of getting the error message every 5 minutes, you get the error message when it actually happens. So presumably slightly faster. The other thing is quite big in the development community is metrics. A lot of people monitor things like CPU load, not because it means anything, because it doesn't. 100% CPU is actually a good thing, because otherwise you have wasted a lot of money on servers which you're not using, right? Because you bought them to use them, presumably. So the CPU load is meaningless. I mean, having an alert at CPU 90%, yeah, you can do it, but it doesn't really mean anything. It can mean something, and it could be a good indication that something is wrong, but as long as you have the bandwidth on other servers, it doesn't really matter. But all of these metrics are useful for graphing and doing things like compound checks. For instance, if your CPU load is high, but your transaction throughput is low, that probably means something. But then you need to start putting these together and somehow figuring out how to do the math to figure out what's wrong. And this is something that you can also do with NSClient. And we have something called events, which is essentially when something happens in your system. Someone starts a program, or a program stops, or a service stops, or something like that. Then an event is emitted. And you can use this, of course, to enforce state. Whenever someone starts Notepad, feel free to kill it for them. They'll be really happy. But you can also use it to automate your monitoring. If someone is starting SQL Server, they probably want to have it monitored, right? So then you can use that event and say, hey, SQL Server is started. Let's, install the monitoring we need to monitor SQL Server, and other things like that. So I think we can do a lot better than having a lot of checks running every 5 minutes. And a little bit of this is what we're going to be looking at here. And the first thing we're going to look at is something that's fairly easy, and that's metrics. Metrics in NSClient can come from three places. They can come from metrics, which are essentially numbers that are floating around magically inside the box. They can come from the normal place, which is performance data, and that's usually when you run the check CPU, just because you want to get the metrics right. And you can also create them from a command line with various submit functions. The easy way to do this, if we want to send them to Graphite, is enable the Graphite client. That's the first line. And then we define our Graphite server. That's the second line. This is essentially everything we need to have NSClient send our metrics to Graphite. So it's not a lot of configuration. It's not complicated to do. It's fairly straightforward. And there is no performance data involved. There's no check every 5 minutes. The metrics are going directly to Graphite, which makes sense. If you want to go through the hoops and doing this through performance data, you can do that as well, right? In that case, we need to have a scheduler that runs the check every 5 minutes. That would be the, let's try this. It's going to be epic if it actually works. Oh, yeah, that would be this line. Yeah, no, I think I'll skip without it. Then we need something that runs the check CPU check, right? That's the check system module, which we need to enable as well. Then we need to run this, and because I don't want to wait 5 minutes, I do it every 5 seconds. And then, of course, we need to send the data somewhere, in this case, Graphite. And then we need to actually define the command. So it's not a lot of configuration, but it is a couple of more lines than just connecting Graphite to NSClient. So now I'm going to do the bold thing of trying to demo this. And that's going to end spectacularly bad, usually. But we'll see. Sometimes you're lucky. So what we have here is, let's just do this. Configuration is the first example we have. So we enable Graphite client, and we set our Graphite server. And we start NSClient. And hopefully, if we go to Graphite and create a dashboard, oh yeah, up here it is. Might have some graphs. We'll see how that goes. Graphite, metric, NSClient, my computer name, and these are some internal metrics. So we can, for instance, see, let's do threads instead. How many threads NSClient is using for its internal scheduling. And since we haven't run this for very long, let's reduce the time frame. So 2 lines of configuration, technically, and we have Graphite connected, right? Now let's move on to this slightly more longer example, where we had the scheduler and the check system thing, and we had the schedule running every 5 seconds, and we're submitting the data from, or the performance data from check CPU. And hopefully, if we go here, oh, that sucks. Oh yeah, there we have it, CPU. And we can do status, which is, of course, up or down or warning critical, that kind of thing. And if we, where do we have add query? Go down here. CPU. Total for, well, let's do 1 minute. That is the usage or load coming from the performance data. And the reason why it's going up is because there is no performance data, so the average for the last minute is 0 for the first half minute. Right, so now I'm gonna go back to my presentation, hopefully, if I succeed in this, and try to continue. Yes, awesome, right? Demo, and it worked. Yay for me. The next thing we're gonna do is connect all of this to Elasticsearch as well, because Elasticsearch is wonderful, right? I don't agree. But let's not go there. Anyway, again, we need to enable the module, because it's a modular monitoring tool, so we need to enable the Elastic client. We need to set the address of our Elastic server where we can submit stuff. And that's pretty much it. So let me just move back and see how that turns out. That's what we're going to do. And then that, and then exit. Type demo, could it be 3 we're at, or is it 2? Elastic, super. Let's do, oh yeah, here I have it, 3. Right, so now if we go to Kibana, Oh, this is probably not going to work out. Yeah, exactly. We need to add index, NSClient underscore metrics. No, there we have it. And hopefully we can now see our metrics here. Yay, awesome, right? Again, fairly straightforward to do. What we also can do now, because this is a log thing, is add another index. Oh, no, there. For NSClient underscore log is, no, log. And if we go back here and we select the other index, what we have now is the log from NSClient going to our Kibana server. So these messages hopefully correspond to these messages. That's the theory anyway. You never know if I'm lying to you. Right, so now we have Grafana there, we have Kibana there, and everything seems happy, right? So let's just fire up the presentation and move on again. The next thing we're going to look at, because now we've sort of covered metrics from a high perspective, is events, you know, when something happens. And you can probably see that this is not going to end up badly or end up good, right? Because he's happily opening his beer and something is probably going to happen. In our case, what's going to happen is that we're going to look at event logs, because that's the normal event stream that people are looking at. But you can have events coming from event logs, you can have them coming from log files, but you can also have them coming from CPU, memory, processes, and things like that. So events can come from a lot of places. In this case, we're going to have a little bit more configuration because the event log is containing thousands of messages which we're not interested in, so we need to do some filtering. But in essence, we need to enable the check event log module. Then we need to say that the Elastic client is going to subscribe to our events coming from the event log. Then for some bizarre reason I've always hated, you need to enable something here. It doesn't really need to be there, but it's required. And then we need to set up the messages we're going to capture. In this case, it's the application log, and we're going to capture everything that is an error and send it down as an event. Then to try this out, we can create some events in our event log, and just to see them going to our Elastic server. So let's see if we succeed in this. Exit. See if this is the right one. Yes, awesome. And now we need to go here again, add a new index. I don't really know why I have them as different ones, but it seemed like a good idea at the time. Events. No, that sucks. Let's refresh. This is bad. Why doesn't it pop up? Is it long? No. Then we already have event log. No. Oh well. Where can I see what it's called? Oh, wait. We haven't sent the message yet. So there is nothing. Thank you. Well, why didn't you tell me that? Let's see if I have it here. So now, whoa, yeah, sorry. Typographical quotes. Right, now we have submitted a message. And let's see if it was event. Oh, thank you. Sometimes demos are bad for you. Right, so let's move to the other index, and hopefully we have this message here. Yay, awesome, right? Errors are cool. So again, fairly straightforward, but a little bit more involved than the previous example. And let's move back to something a lot more fun. No, it's not going to be more fun. It's going to be pretty much like this all the time. Right, so we mentioned other kind of events. So here, oh, yeah. You want to see the slides or not? Awesome, now we have slides. Question is where we are. Oh, yeah. Sorry. we mentioned other kind of events, right? So we had event log there, but here let's emit an event whenever we launch Notepad. And it's kind of the same or similar setup. So the events we subscribe to, we need to add the Notepad stuff at the end. And then we need to create something that captures that Notepad is started. So in essence, what we're saying here is that listen to the process notepad.exe. Whenever it's new, emit an event. So let's see how that turns out. Hopefully better than last time, right? Let's see. Yeah, wrong window. That's a good start. And Notepad. And let's go to Kibana and collapse this and search. No. Yeah, there we have it. And here we can see a lot of stuff. And here is the not so funny bit, because all of these different kind of events will have different metadata. So we need to refresh the index for it to be able to, index them and things like that. But again, we can sort of get a lot of stuff in here. And if you want to have a whole bunch of cool events, that's all nice and dandy. The benefit of this over running something like check event log or check process or something like that is, first of all, this will react in real time. So whenever the event is emitted, it's submitted directly. But more importantly, running things like check event log is very expensive, because whenever you run that command, it needs to go and parse the entire event log and sort of figure out what's happened since last time. Whereas if you're listening to something and submitting it in real time, it's a very, very cheap operation. So we have some people who have, hundreds of check event log commands they're running, and those servers are spending a lot of time parsing the event log. When they switch to the real-time view, it's a lot quicker. So that's, oh yeah, we need to switch back to this guy as well. There's a lot of switching here. Yeah, I'm one slide ahead. So now we're going to move on to something completely different. And unfortunately, it's different bad, because this is going to be really boring. Dreadfully boring. It's going to be theory. There's going to be no more demos. So yeah, brace yourself, or, feel free to pop out, grab something to eat or drink. Right, so what happens when you run your, check whatever you're checking? Well, normally what's happened is that your monitoring server connects to some sort of socket handler, and then you fork some process, and something is executed, and something is returned back, right? Fairly straightforward. Now, if you're using NSClient, it's pretty much the same, right? You can use NRPE, or you can use the Rust stuff, or depending on where it comes from. But essentially, Icinga sends some sort of signal to NSClient. NSClient runs a command, and it returns something back. Now, one difference between NSClient and, for instance, NRPE or something like that is that there is other things than just running scripts, because there's built-in checks. There are also other protocols. You can run REST, or you can use check-NT, or you can use other things to talk to the client. And there is a whole bunch of fringe modules like Graphite, Elastic, SMTP, and things like that. But there is one fundamental flaw here, and that's this arrow, because it goes one way. And what if your script wants to tell your server something? There's no way to do this in this model, right? Because it's always initiated from one end. Or you can always flip it around, in which case it's initiated from the other end. But there's no dialogue. There's no way for these two to actually talk to each other and figure out what they should do. And a lot of getting around this is, for instance, why you need things like Icinga Director. Because that's a way for you to build a module that can talk to your system and figure out what it's actually going to do. But what if you could just run, check SQL Server and, oh, yeah, we have 5 SQL databases. Let's add them and let's monitor them. That kind of thing is not possible with the sort of infrastructure we have. And then you have other questions. So how do I do with my configuration in my script? You usually end up in 2 scenarios. Either you have a very long command line, or you need to edit the script to put in some parameters at the top, right? Or maybe someone has done something fancy and have a configuration file. And then you have the scenario where you have 2 checks that sort of want to talk to each other because they need to do some sort of communication. It's not really possible because, again, someone wrote this script and someone else wrote this script, and there's no infrastructure, there's no way for them to coexist. They are just single instances of each other. And then we have things like state. What if your script needs to know what happened the last time it ran? Well, you can always say, yeah, I'm going to write the temp file somewhere and then pick it up. But it's kind of clunky, right? And there is no infrastructure for it. So that's why I tend to think that most scripts are stupid. And they tend to be not very user-friendly and quite difficult to get to work. And it always involves some sort of hand tinkering somewhere to get this set up. What if we could take this script and somehow move it inside our monitoring solution? And then we could somehow have all of these communication, we could have all of these coexist, and somehow make things a little bit easier and more standardized. This is, of course, possible, otherwise I wouldn't have mentioned it, right? So this is something in NSClient that's called internal scripts. And those are scripts that are written in Python, Lua, and REST, and they run inside NSClient. And they have access to a lot of features that NSClient provide for them. Things that make writing the scripts more standardized, more easy, and more powerful, because you can access a lot of these functions that you wouldn't otherwise. Just looking at your average hello world, this is a Python example, but as I said, you can do the same in Lua. We need to import some stuff from NSCP, which is the provider of the functionality. Then we have the init function and the shutdown function, and we can just say hello and goodbye and things like that, right? So this is your average hello world. Not very fancy, right? But if we look at your average check command, which is written in Python, it looks a bit like this. If we turn it into an internal script, it looks fairly similar, but a big difference. And the biggest difference is that here we have a function, which is what is providing the functionality. So it's not the script that provides the functionality for a check command, it's a function, right? So we bind the function to a check command, but because it's a function, it has access to all of these and it's running inside, right? But you might say that, yeah, it still does the same thing as the normal script, right? So what's the big deal here? And the first thing you probably will notice is that we have access to configuration. So what we can do is we can, say, hey, I have this configuration key here, and we can give it the description, we can give it a name, and things like that, right? And we can fetch the value, we can change the value, we can save it, etc., etc. And this means that we automatically get the web UI for our script. So we can go in and configure it easily somehow, or depending on how you like to do things. But regardless, you get the description for what all these values are in a standardized fashion, right? If you wanted to have state in your script, it just works, right? Because the script is started and then it's running throughout. So all the global variables you have in your script are, by definition, stateful. There's no need to read a file or write a file or do anything. It just works, right? And if you want to communicate, between your commands or between your scripts or, with other parts of NSClient, you can do that as well, because you have access to the infrastructure that is provided in NSClient. So things like running other checks and modifying the result and things like that is fairly simple and easy to do. And then we have the whole metrics bit we talked about. Supplying metrics is a simple one-liner. We just return a hash map of whatever values we want to send to Graphite or Elastic or wherever they're going, right? And we can also subscribe to metrics if we want to do something like a compound check. So we can look at the CPU and some other value and figure out what we're going to do with it. And of course, the events are there as well, right? Otherwise, there would be kind of strange to leave them out, right? So if we want, to do something when Notepad is started, we can do that. And that means that whenever SQL Server is started, we can say, hey, add this configuration to start monitoring SQL Server. Or we could even go to Icinga and say, hey, start monitoring my SQL Server for me. I have these databases without any configuration or anything like that, right? So all of these things we have mentioned before, which we were sending to Graphite, which we're sending to Elastic, we can sort of utilize them ourselves in our scripts to build better scripts. And in the last version, we introduced something called zip modules, and these are essentially scripts which you package inside a zip file, and then you can provide a little JSON file that sort of tells NSClient what it should do with the zip file. And this means that you can actually create your own modules without having to write, well, you need to write some Python code depending on what you want to do. But without having to write a lot of code. And the only thing you need to do is NSClient to say, hey, load my module, and everything else just runs from there. So I think we can actually write smart scripts if we were so inclined. And the big question you're probably asking yourself now is, why is he telling me this? I don't know. I stopped listening 10 minutes ago. It's so boring. I don't even write scripts, right? But what if we had our configuration as code instead of as configuration? Because one of the biggest questions, or one of the most frequently asked questions I get from people using NSClient is, how do I distribute my configuration? Because a lot of people live in a Unix world, and they have 5 Windows boxes. And it's really cumbersome because they don't have a whole infrastructure to deploy and change things on their Windows servers. They just inherited these boxes that they don't really like, right? But what if you could put your configuration as a script and just deploy that, right? All of a sudden it would be easy, or the problem of managing your configuration would just go away. But what if we could take this one step further? What if we could actually talk to Icinga through using these features, right? And Icinga has this nifty little REST API, and this means that we can create our Icinga module, and then we can use the configuration in NSClient to tell us, over here you can find Icinga, you log in with the user and the password, and all of a sudden you just have monitoring connected to Icinga. Now, I would like to demo this, and unfortunately, Icinga people like Vagrant. Vagrant doesn't like me. So I spent last week, ended up with this little guy. So apparently, after you read it, you realize that you need to be admin to run it. They had to write an entire essay about it. but somewhere in the middle, it says that you need to run this program as administrator. So yeah, okay, I can run it as administrator. And then you end up with this guy. And after reading another essay, you realize at the end here, it said, standard strange character Excel. And I was like, Swedish is not supported. And then you run it again, and you end up with an even longer essay. And this is about when I say, okay, I'll go look for something else. So I went to my trusted Linux machine and said, okay, Vagrant on Linux, how hard can it be? So yeah, another essay. And this one is really interesting. But if we look at the end here, what they're essentially saying is that I should report a bug to the NetSSH project. And I don't think that the Vagrant bug is actually a bug in NetSSH, but it could be. It could be. But no, I think just Vagrant sucks. That's what I'm thinking. But I'm not saying it, I'm thinking it. Right, so we were talking about pushing configuration, right? So we still have this little issue of the zip file that needs to go on all your 5 Windows machines. And because you're too lazy to copy it there manually, we solve that problem as well using another of these zip files. So there's something called remote modules, which will essentially download another zip file for you from a server of your choosing. So this means that whenever you start NSClient, it will download this zip file for you and add it as a module, and then reload the configuration or whatever is required, right? And there is even a command embedded if you want to force this and have your clients reload the configuration if you updated it for you. So that just leaves the little tiny bit to get these 4 lines into the NSClient.ini file. And fortunately, we also have a solution for that, because in Windows there's something called MSI, and that's what you install, right? And there's a command line for installing MSI files. So essentially you can do something along the lines of this, where you can sort of say, install it into this folder, put the log file over here, and weird stuff like that. But there's a whole bunch of other things you can tell it too. You can tell it what your NSClient password is, what configuration you should include, what monitoring tool you have, and the interesting bit we want here is conf set, because that can set arbitrary configuration keys. So essentially, we can use that command to set the 2 configuration keys required to download your configuration for you. So essentially, if you run this command on your 5 Windows machine, everything should be taken care for you. Awesome, right? So let's see if this works. And this is the scary bit, because this didn't work last time we tried it. Or I tried it. So we'll see what happens. Right. Yeah, we should actually do this. So this is my 6th configuration file. The only thing we have is my module. In this case, I'm not downloading it because I don't trust the network. But we're going to see if we start. Was it 6? Yeah. If we start NSClient now, it will, restart and start doing all the stuff it did before, except for the fact that our config file is now configured. So NSClient wrote its own configuration file without me having to do anything. Well, I had to write the script that did it, obviously, but that's pretty much it, right? So hopefully this will alleviate the problem of managing your configuration infrastructure on your 5 Windows machines. If you have more than 5 Windows machines, you probably want to have the infrastructure anyway. So then you might want to look for a tool that actually does this instead of something I hacked together in the basement. Right. And unfortunately, I'm not doing so good on time. But in your favor, because this is the last slide. So you'll have to come up with a lot of questions, or they'll be mad at me, and I'll get no T-shirt next time either. So thank you for listening.
So when do you
start with
rename
questions over there?
Michael? When do you rename NSClient to NS Server?
What server? No.
It means you did so much stuff in it. It's more a server like a client right now.
Yeah. There's that.
So
that's when I launched the non-open core, or the open core version. We actually have a question here by the guy in the fancy T-shirt, or T-shirt, sweatshirt, I guess it is. But
that's Robert, our highest.
Really colorful.
So I'm again.
Yeah. Nice questions. No mean questions. Yeah.
Okay, I try to be nice. You specified that the Icinga client has to use the API user and the password, but what for rights does the user need to get its own checks into Icinga?
Could you take that again?
The Icinga API user needs some rights.
With the microphone slightly closer.
Slide.
Thank you.
Okay. Okay, then we repeat this. The API user which you have to configure the Icinga API, which rights does he need to configure itself into Icinga?
Oh, that's a good question. I assume it needs a lot of rights, because what it will do is actually add a lot of configuration to Icinga, and then it will start submitting stuff passively.
And can I use the same user again for all the other servers, or need I a different user for each of my 5 boxes?
Well, I mean that is the Icinga API you're connecting to, right? So as long as you have the one Icinga server, then it should be the one user.
Okay, thank you.
You're welcome. Any other questions?
More questions?
No.
So we have 5 minutes.
Yeah, that's like easily 6 more questions. You can do difficult questions as well if you want. Evil ones, I'm happy to oblige.
Thomas, an evil one?
Yeah. Why does NSClient suck? Why is it so hard to use?
Oh, we have an evil question over here.
Yeah? Oh, I'm good.
Wait. I give you the microphone.
Okay, so I see that this is still a 0.0 version. So what's your plans for future features? And when you will decide that it's okay to say that we have 1.0 version?
Yeah, that's a good question. When I have an answer to that, I'll have a press conference. I think that you should be careful, because version numbers are expensive, so you shouldn't waste them. 10 years ago I had a roadmap going to version 1. I've deviated a bit. But eventually I'll somehow get by. To be honest, I think that once the REST API is finalized, there will be a version 1 actually. So hopefully this year, but we'll see. Yeah.
So if you here, right here, over here, to the middle here.
Oh
right
yeah,
here.
sorry.
If you're using the Elasticsearch feature, does it mean that every client needs access to Elasticsearch? And by that has access to every operation on Elasticsearch?
That I don't know actually, but in my view, there is no privileges in Elasticsearch. That's what you have Splunk for, right?
Yeah. So Does it mean that every client can just delete data in Elasticsearch?
Possibly. I mean, again, I don't know Elastic that well, but in my view, you can do whatever you want with the one account I have, and I haven't been able to find anything else. But I'm no expert.
That's the YOLO ops paradigm. Sometimes I know you for years, I don't know what you're thinking. Any questions?
Yes. Now it's like 2 more questions, and then we can go. Or I'll start asking you guys questions. I'm fine with that as well. No, well.
Okay, thank you very much, Michael.